electric field 1. We'll consider 3 charges plus 10 Coulomb minus 20 Coulomb and 16 Coulomb that are distributed as shown in the diagram above. As we have seen in this diagram, here I have the plus 10 Coulomb charge placed here. I have the minus 20 Coulomb charge placed here. Then I have the minus 16 Coulomb charge placed here. The distance between the plus 10 Coulomb charge and the minus 20 Coulomb charge is 3 meters. The distance between the plus 10 Coulomb charge and the minus 16 Coulomb charge is 2 meters. Now, we are to find the resultant force acting on the 10 Coulomb charge. We are to get the resultant force acting on the plus 10 Coulomb charge. In doing this, the first thing we need to do is to get the force of attraction between the plus 10 Coulomb charge and the minus 20 Coulomb charge. Let's call that force of attraction between them, let's represent it with F1. And from our formula for force between two charges given by Coulomb's law, the force between two charges given by Coulomb's law says that F is equals to K Q1 Q2 all divided by R square. F is equals to K Q1 Q2 all divided by R square. So this is the definition of Coulomb's law. Okay, and we also know that that K is given by 1 divided by 4 pi epsilon naught. Our K is equals to 1 divided by 4 pi epsilon naught. Okay, so if we put that inside our formula for F, that will give us F is equals to 1 divided by 4 pi epsilon naught multiplied by Q1 Q2 all divided by R square. Okay, now the force between the plus 10 Coulomb charge and the minus 20 Coulomb charge is represented with F1, which is equals to 1 divided by 4 pi epsilon naught times 10, which is the 10 Coulomb charge, multiplied by 20, which is the 20 Coulomb charge, all divided by 3 square. Where did we get 3? The distance between the two charges, that is the 10 Coulomb charge and the minus 20 Coulomb charge. Okay, now but note that our K is 9 times 10 raised to power 9 is a constant. The constant K has the value 9 times 10 raised to power 9. Okay, so multiplied by 200, that is 10 times 20, 200, and then 3 square, that is 9, all divided by 9. Okay, if you press your calculator correctly, this will give us 2 times 10 raised to power 11 Newton. 2 times 10 raised to power 11 Newton. The second thing we are to do is to get the force between the 10 Coulomb charge and the 16 Coulomb charge. The force between the 10 Coulomb charge and the 16 Coulomb charge. Okay, so we use the same formula given to us by Coulomb's law, which is KQ1 Q2 all over R squared. Okay, so going to F2 now, that will be 9 times 10 raised to power 9 multiplied by 10, the 10 Coulomb charge, multiplied by 16, the 16 Coulomb charge, divided by 2 squared. This 2 is the distance between the two charges, the distance between the plus 10 Coulomb charge and the minus 16 Coulomb charge that we are looking for. The distance between them is 2 meters, and that is why we are using 2 square here. Okay, so if we divide correctly, that will give us 36 times 10 raised to power 10, and in standard form that will give us 3.6 times 10 raised to power 11 Newton. Very important for you to put Newton. Okay, good. Now a vector representation of what is going to happen here is what we have in this diagram. Okay, so the F1 will be in this direction, that is the direction of the horizontal, and our F2 will be in this direction. Okay, and don't forget we are to get the net force. The net force will be the diagonal passing in between the F1 and the F2. The net force will be represented with F, will be the diagonal passing through the in between the F1 and the F2. Okay, and that is why we have written that the net force F is equals to F1 square plus F2 square. Then we take the square root of that. Okay, then we also have F, which is equals to square root of our value for F1 is 2 times 10 raised to power 11 Newton. So we'll put it in 2 times 10 raised to power 11 all squared plus the value for F2, 3.6 times 10 raised to power 11. We put it in 3.6 times 10 raised to power 11 all squared. By the time we add this together and we take the square root, that gives us 4.12 times 10 raised to power 11 Newton. 4.12 times 10 raised to power 11 Newton. Are we true? No, we are not true yet. Whenever we are looking or we are to get a vector quantity, force is an example of a vector quantity. We don't just get the magnitude such as this. We have gotten the magnitude of the force. We will also obtain the direction of the vector. We will also obtain the direction of the vector. Don't forget, the question asks us to get the resultant force acting on the 10 Coulomb charge. So we don't just get the magnitude of the force, we also get the direction in which the force is acting. Okay, and how do we do that? Let's represent the angle between the net force and the vertical with an angle theta. Let's call it theta. This is my theta. I hope you can see what this is, my theta. Okay, so from our SOHCAHTOA, I can write that tan theta, which is TOA, is equals to opposite over adjacent. So the opposite to this angle is this place. The opposite to the angle is this place, and the adjacent of this angle is this place. Okay, so that gives me my opposite to be F1. If this line is F1, if this line is F1, this line will also be my F1. If this line is F1, this line will also be my F1. Okay, then we have tan theta is equals to F1 divided by F2, which is my adjacent F2. Okay, so the value of my F1 is 2 times 10 raised to power 11 from here, and the value of my F2 is 3.6 times 10 raised to power 11 gotten from here. Okay, so dividing appropriately will give me 0.55. Okay, so if tan goes to the other side, it becomes arctan. It becomes arctan, okay, and that will give me arctan of 0.555. Okay, so if I press that correctly on my calculator, that will give me 32.3 degree. 32.3 degree. Okay, so the net force that will act on the 10 Coulomb charge will be 4.12 times 10 raised to power 11 Newton. Okay, and it will act in a direction 32.3 degree to the line joining the plus Coulomb and the minus 16 Coulomb charge. Okay, so I've given it the magnitude, I've gotten the magnitude, and I've also gotten the direction in which the force is going to act. Thank you for your listening attention. See you in the next class. Bye.